This project is being undertaken at the request of PTE Hydraulics to improve the operator safety of the assembly and packing workshop in their Brisbane premises. Currently, operators in the plant are physically lifting and manoeuvring the hydraulic cylinders, weighing up to 100 kilograms to and from their workbenches. A lifting system that removes the weight strain from the operator is required, including gripping, lifting, and manoeuvring capability. The project has been split into 4 components. A gripping mechanism will be required to attach onto and hold the weight of the cylinder. The linkage between the gripper and the jib crane must be designed and be vertically adjustable. A pneumatic actuation system must be designed to power the gripper and the lift. And finally, the system needs the capability of rotating the cylinders between their vertical mounting and the horizontal workspace. The goal of this project is to prevent injuries to the operators caused by repetitive lifting and manual handling of the heavy cylinders. There is a single jib crane available, however the lifting sling is slow and cumbersome to use. The project also aims to match or improve the time efficiency of the current process, to reduce cycle time and prevent operators from reverting to manual handling. This time efficiency will determine the success of the project. Safety and function are the 2 major concerns. If the prototype system works to specification, then there will be no danger to the operator. However, if the use of this system slows the operator's job, then they may revert to manual lifting, endangering themselves and marking the project a failure.
Hi, my name is Mitchell. My role as a technical officer focuses heavily on the design of the hydraulic cylinder gripping mechanism.
Due to the large variety of hydraulic cylinders PTE produces, the gripping mechanism must be very versatile. I will be responsible for ensuring the design of the gripping mechanism is fit for purpose and user-friendly. The gripping mechanism will be designed to suit as many different hydraulic cylinders as possible. An effective design of the cylinder gripping mechanism is critical for a successful overall solution for PTE. As the technical officer, I will be working closely with the other team members in the design phase. This will ensure the whole design is cohesive and collectively meets the design scope and requirements.
Hi, I'm Blake. I'm the liaison between my team and PTE Hydraulics. For our design task, I will be focusing on the section between the jib crane and grabber mechanism.
The Oxford Dictionary defines liaison as the communication or cooperation which facilitates a close working relationship between people or organisations. Our team wants to create a healthy and versatile relationship with PTE Hydraulics. It is my role as a team liaison to build this. I am in charge of providing a monthly progress report for PTE to view and provide feedback on. This will allow us to get consistent feedback on a regular basis. We're all about providing the best solution to them and something that they'll really want to use. The manipulator attachment that is to be designed needs to be easily stored out of the way when not in use, not take up a large amount of space, and be able to lift the load. During the design phase, it is important to ensure that it can be attached onto the jib crane and also the grabber mechanism. This involves a large amount of adaptability and working with all my teammates to ensure full functionality of the designed lift assist.
Hello, my name is Brodie and I'm the team leader for this project. My main task is to design the power actuation system, as each of the other 3 aspects will require some form of powered device to provide movement. There are multiple ways to provide power to the system, such as electrical, hydraulic, and pneumatic. Research has indicated that pneumatic is the preferable method, and my focus will be on designing a pneumatic system for our mechanism. To successfully integrate the power system with the mechanism's functionalities will require close cooperation with the rest of the team. This will ensure that I can provide a system to actuate all parts and provide the right amount of gripping force and user adjustability. To achieve end-user functionality, I will also be reliant on prototyping to fine-tune the design.
Hi, my name is Anthony and I'm the team manager. My role is to design the manoeuvrability system to allow rotation between the vertically mounted cylinders and the horizontal workspace.
Manoeuvrability is a major concern for this project, as the transfer of hydraulic cylinders is the weakest element of the current process. A number of possibilities were considered, including winches, levers, and powered actuators. A great deal of collaboration with other group members is required, as this aspect of the design is incorporated into each other component. The research into the attachment segment concluded that a rigid articulated arm would be best to support the mass while providing control. Industrial manipulators are a prime example of this design, and are commonly used in industry. The Aimco torque arm shown on screen is fitted with a gripper on a rotary actuator, with essentially the same function we wish to create. It is likely we will use a pneumatically powered rotary actuator for the transfer, as it prevents the weight being balanced by the operator.
Existing industry solutions to manual handling problems have been investigated to gather knowledge on proven methodologies and designs. The direction of this research has closely followed each team member's specific role and their respective aspect of the physical design. The following diagrams show some of the possible solutions for each aspect. The use of mechanical jaws or a lifting magnet is being investigated for the gripping mechanism. Pneumatics will lightly control all powered features. Torque arms using pneumatic cylinders have been considered to raise and lower the device, and the orientation mechanism is likely to utilize an offset bearing to rotate the hydraulic cylinders from vertical to horizontal.
As you can see on the Gantt chart, our project has been divided according to the assessment milestones of the PDR, CDR, and final project. Over the course of the year, we will be providing a monthly update to our supervisor at PTE to ensure that the project is meeting client requirements. During the CDR phase, additional consultation with PTE will be sought as a final design is produced. Each member will continue to work on their individual aspects, whilst also assisting each other with integration. Once approved by PTE, prototyping will commence prior to the final project report due date, so that we are able to test and redesign for any issues should they emerge. It is our intention to have a full-sized working prototype and production plans for presentation to PTE by the end of the year. In terms of work breakdown, each member will continue working on their designated aspect, whilst also assisting the team with the other aspects and assessment items.
In summary, individually we have discussed our parts of the project design and our role in the team. We have clearly defined our project and scope, shown some examples from our preliminary design reports, and created a project timeline. By the start of August, we should be moving from consulting and finalizing our preliminary design to prototyping and testing in the PTE manufacturing facility. This will carry out through to the end of October, where we will hand over the project for PTE to implement the designed lift assist.